When you hear the word sonar, you probably think of movies with submarines. And in fact, we're talking about the same thing, because a sonar is simply a device which sends out some sound and then listens for its echoes. And by measuring the delay of this echo, it can then calculate the distance of objects. Your phone can do that too, and this is how.
For this experiment, you will need a smartphone with phyphox. Phyphox is available for free on Android and iOS. Just visit phyphox.org and follow the link to the respective app store. You will need damping material to build a cavity to shield unwanted echoes. I use some packaging material, but most soft materials should do the job. For example, you could use some sofa cushions. And you need a reflector. Anything hard and flat should do, like this tray I stole in the kitchen. A rule is nice to verify the results.
The problem with this experiment is that pretty much everything in your environment generates echoes. So you will get an echo from the floor, from the walls, from the ceiling, and about just any object in your room, and the result will be quite incomprehensible. So instead, we will build a cavity and then set up a well-defined reflector.
Use your damping material to shield your phone from all but a single direction. Place your rule next to the phone. Note that on phones usually the speaker is placed on the opposite side of the microphone, making it hard to define the distance of 0. If you want an exact definition, you can try to attach an external speaker to your phone. You should open the experiment Sonar in the audio section of phyphox. You might want to connect a second device to get your results, as your phone is hard to reach from within the cavity. Visit phyphox.org to learn more about setting up the remote access.
I will now start the experiment and use the tray to create echoes at different distances.
The phone uses its speaker to send out a so-called chirp, which is a special sound that can be easily recognized by phyphox. It is a simple tone that rises its pitch over 5 milliseconds, which is so short that you will perceive it as a click. Actually, phyphox will send 5 chirps, so you will hear 5 fast clicks. Simultaneously, phyphox will record everything with the microphone and it will compare what it hears to the chirp it just sent out. The result is a graph of how much the recording resembles the original sound over time, which mathematicians call a cross-correlation. The graph shows at which time the recorded signal sounds like an echo, and, using the speed of sound, phyphox will display it not as a function of time, but as a function of the distance. Now, in the experiment you will see that you can tell where the tray is, as it clearly produces a strong peak in the graph. Here it is at 50 centimeters. Here it is at 1 meter. And here it is at 2 meters.
That's it for the demonstration of the phone sonar. If you want to learn about other phone experiments, visit phyphox.org and see you next time.
We hope you enjoyed this video, and for more lessons and videos go to freqphysics.com.